I would say, why do we learn recursion? So I'll tell you, we learn recursion because most of the data structures, or I would say all the data structures that we have, they are recursive in nature. So here I am saying data structures are recursive in nature. What I mean by data structures are recursive in nature, let us understand that first. Let us take the simplest data structure, which is an array. Okay, what does recursion do? Recursion solves a very small part of a big problem and then delegates the remaining part to the next call. That is what it does. And that next call is the similar kind of problem only. If you look at an array, I can say this array can be thought of as, let's split its one element and let's preserve the remaining part. So I can say it can be split into an element, a single element, and a remaining part, and this remaining part is again an array. The only difference is that this is an array of size n and this is an array of size n-1. Now again, this can be split into an element and a remaining part, which is again going to be an array, just that it will be of smaller size. So no matter what data structure you have, you can use recursion on it. Why? Because you can always take away something from it, and then whatever remains is the same thing with a smaller size, right? The same is true with trees as well. So let's say you have got a very simple tree, which looks like this. Yeah. In this tree also, you can say, what I can do is I can take away this root. So let's say this is our root. Let me take it away. And what remains is two smaller subtrees, correct? So if you have been given a big tree, which was like that, then you can say this is a combination of a root, which you can say is this, and then there is a left subtree, and then there is a right subtree. These three things make up for a complete tree. So what do you see? Again, this tree is a recursive data structure. So whenever you are solving any question on top of a tree, you have to visualize a tree like that. You do not have to visualize a tree as so many things which are jam-packed. Just visualize it as if there is a root. So do something with the root and then do something separately with the left subtree and with the right subtree. Because if your algorithm can deal with left subtree and right subtree properly, then it can deal with the big entire tree also, because the entire big tree is also a tree. The only thing that differs is size. Okay, cool. So from here, I want you to understand it very clearly that whatever you have learned in recursion will be directly applicable in case of the trees.